Hey guys, so for those of you who might be looking, to spend their free time doing a little bit of trig, I thought I'd put this together for you. I don't know why, but I really like solving these equations, so I thought maybe some of you would too. And it helps me stay a little bit sane, so here we go. So a lot of this, the challenge piece is dealing with factoring or using the trig identities, so that's what we're going to look at. So let's take it back to just regular old algebra 2. If I gave you x squared minus 3x minus 2 is equal to 0, and I asked you to solve that, well, you would first have to factor and say, okay, what multiplies to negative 2? That adds to negative 3. I think it's negative 2. Oh, I think that's supposed to be positive 2. Sorry. It'd be, and that means I need to change this one. Sorry, it'd be negative 2. What multiplies to positive 2 and adds to negative 3? Negative 2 and negative 1, right? Multiply to positive 2, add to negative 3. So my factors are x minus 2, x minus 1, and my solutions are 2 and 1. Okay, simple enough. So if I give you something really similar, but this time it says secant squared x minus 3 secant x plus 2 is equal to 0, we can factor it in the exact same way. We just have to remember that instead of it being x minus 2 or x minus 1, the piece that's representing our x here is the secant of x, right? So this is like having the secant of x squared minus 3 secant x plus 2. So no different than if they were x's, just our factors are going to look a little different. So when I factor it, it would be the secant of x, and our two numbers were negative 2 and negative 1, so minus 2, and then secant of x minus 1. If I want to solve that, then I would take each one and set them equal to 0. Right, zero product property. And then I could add 1. So we're looking for where the secant is equal to 2, which really means where's the cosine equal to 1/2, or where is the secant equal to 1, or where is cosine of x equal to 1, right? The reciprocal of 1 is still 1. So then you could use your unit circle, solve them just like we have been doing. And don't forget to add on pi n plus pi n or 2 pi n to get all the values at the end. For the second one, if I had cotangent x times cosine squared x equals 2 cotangent x, well, when we start to factor something, remember we want everything on one side of an equation. So let's write this as cotangent x times cosine squared x minus 2 cotangent x equals 0. So I don't see, there's not 3 terms here. It's not a trinomial like we had here. But I do see that they have both a cotangent x and a cotangent x here in common. So what I'm going to do is factor that out as the greatest common factor, taking a cotangent x out. And then what would be left is cosine squared x minus 2. Right? So my two factors are cotangent x, cosine squared x minus 2. Again, setting them both equal to 0, we could solve for the value of x that we want. So adding 2, then cosine squared x is equal to 2. Take the square root. So we're looking for where the cosine of x is equal to plus or minus the square root of 2. Now, cotangent being equal to 0, that's one we can find on the unit circle, right? So that's where we have cosine divided by sine. We want it to be 0 over 1, or 0 over negative 1. So looking for those points, those would be your quadrant angles, like 0, 90, 180, 360, 270. But just the square root of 2 doesn't actually show up on the unit circle, right? So this is where you'd use your inverse functions like we did before. So cosine inverse of the square root of 2 and cosine inverse of negative square root of 2, those would give you two x values there. And truthfully, you can use that all the time with your calculator, but it's a lot easier anyway, I think, to look at your unit circle. All right, so let's think about this other one here. 2 sine squared x minus sine x minus 1. So for simplicity purposes, I'm going to rewrite this without the signs because it's a little confusing. So think of it as 2, let's say y is equal to sine squared x, or sine x. So 2y squared minus y minus 1 is equal to 0. This is a situation where we need to slide and divide, so I'm going to slide the 2 to the end. So I have y squared minus y minus 2 is equal to 0. Now I need two things that multiply to negative 2 and add to negative 1. I think negative 2 and positive 1. So y minus 2, y plus 1. And then because we slid the 2, we have to divide by 2. So we get y minus 1 and 2y plus 1. Now because I made y equal to sine x, my real factors are sine x minus 1 and 2 sine x plus 1. And then you guessed it, just like we did before, take each factor, set them equal to 0, and solve individually for x. So this is sine x equals 1. This would be sine x equals negative 1/2. Look on your unit circle for where those two values would occur, and then find what your x value would be. All right, could get a little trickier if I maybe give you something like 12 sine squared x minus 13 sine x plus 3. So again, if we let y equal sine x, then it's really 12y squared minus 13y plus 3. And I should say here, I just picked y because I wanted a different variable than x, but you could replace sine with any variable. I'm just trying to write it in a simpler way for us. So we could try the slide and divide here. Y squared minus 13y plus 36 is equal to 0. Oh, actually, this does factor 9 and negative 9 and negative 4. So this was a poor example to use. And then divide by 12. And we could reduce. So we get y minus 3/4, y minus 1/3, or 4y minus 3, 3y minus 1. And that's really 4 sine x minus 3, 3 sine x minus 1. But let's say I couldn't figure out the slide and divide. Remember, you guys can always use the quadratic formula. So let's retry this problem, but with quadratic formula. So 12y squared minus 13y plus 3. Okay, so that's my A, B, and C. And remember your quadratic formula, negative b plus or minus the square root, b squared minus 4ac, all over 2a. So I'm just going to substitute all of that in here. So x is equal to 13 plus or minus the square root of 169, that's 13 squared, minus 4 times 12 times 3, all over 24. So 13 plus or minus the square root, let's see, 4 times 12 times 3, it's too early in the morning for me to do that. 144. So 169 minus 144 all over 24. This should give me 25. So we get 13 plus or minus the square root of 25 over 24, which is 13 plus or minus 5 over 24. So 13 plus 5 divided by 24, and 13 minus 5 divided by 24. Right, so that gives me 18/24, which if I take a 6 out would be 3/4. and this is going to give me 8/24, or 1/3, right? Well, when you know 3/4, 1/3, right? So if I wanted to, back at this step of factoring, I could have said sine x minus 3/4 is equal to 0, and then all I have to do is add 3/4. And then if you're thinking about, so same thing here, this would tell me, because we didn't really use x, oops, that should have been y anyway. We used y. What we really want to replace it with is the sine x, right? So sine x is equal to this answer of 3/4, and sine x is equal to the answer of 1/3, right? These are not on our unit circle, so you want to go and use the inverse function on your calculator. So put in 3/4, do second sine, and then see what you get for x values there. All right. And then the last challenge piece here is sometimes they give you equations that are written with two different functions, and we can't figure out any way to solve it unless we put them in terms of the same function. So this is where your trig identities are really important. If you look in your list of Pythagorean identities, we have secant squared is equal to 1 plus tangent squared. All right. So what I can do here is I can replace secant squared x, that whole thing, with 1 plus tangent squared x minus 2 tangent x, and then I'll bring that 4 to the other side so it's all set equal to 0. So that is going to be the beginning here. And then let's combine some like terms. So I can combine the, let's see, I can combine the 1 and the -4. So I get tangent squared x minus 2 tangent x minus 3 is equal to 0. Now if we let y equal tangent x, then y squared minus 2y minus 3 is equal to 0. Right? So my factors now could be y minus 2, y minus 3, y plus 1, which is really tangent x minus 3, tangent x plus 1. Set each equal to 0, figure out, so in this case, tangent x would equal 3. Not on our unit circle, so use tangent inverse on your calculator. And over here, though, you could find, so tangent x would equal -1. You could find a place on your unit circle, yeah, where, sorry, I had to visualize the unit circle quick, where tangent is equal to -1. So it'd be one of your pi over 4s. So that one's in the unit circle, but 3 isn't, so use your inverse. But the takeaway here, you guys know the rest of the steps, is sometimes if you can't figure out a way to solve it, look at your trig identities and see on that blue sheet there, and see if you could replace anything in the equation to make this problem easier for you. In this case, I knew tangent was equal to sine over cosine, and tangent's also equal to 1 over cotangent. But neither of those trig identities would help me deal with secant. So because they weren't in terms of the other function that's there, I didn't really want to use those. Okay, so that's why I didn't go with either of those. But I do know that secant squared is equal to 1 plus tangent squared. And so that would give me another tangent, which is actually helpful. Okay. So if you made it with me this far, if you stuck with me this far, go ahead and try a few of the challenge problems. They'll give you some extra credit if you do those.